Hi, everyone. Welcome to another edition of Metaflow Office Hours. We have a super exciting session coming up today. Just a few days ago, there was this announcement about the Metaflow Runner API. This has been a long requested feature providing a way to run Metaflow flows, programmatically, and has use cases for automating these flow runs in CI/CD systems, executing flows in notebooks, etc. One of the main developers behind this feature, Madhur Tandon, is with us today. Madhur will talk more about what the Runner API is, how it works, and show us examples of how to use it. Madhur has been working in data science, data infrastructure, and Python for several years now. He was an engineer at Sundial. Before that, he was a scientific software engineer at QuantStack for a couple of years. He's been a researcher. He's been a Google Summer of Code participant for a couple of years, I believe, and a speaker at conferences like PyData. Madhur, welcome to Metaflow Office Hours. Over to you.
Well, hi everyone. I'm Madhur, and let's begin, I guess, without wasting much time. So I'm going to quickly share my screen, and I hope you guys can see the blog that we published about the runner. So actually, before going to the blog or perhaps the documentation, let's start with examples directly. So let's do that. So here I have a very simple hello flow. It has 3 steps: start, mid, and end. And it really does nothing. It just prints 3 different statements: start, hello world, and end, right? So I have some snippets here that I can show on how it is supposed to run. So we first import from Metaflow import runner, and to the runner we pass a flow file. Now the flow file is actually present in the same directory. So I'm just referencing it by helloflow.py, which is present here, which I showed you here. And by default, the show output flag is turned to be true. But yeah, I'm right now turning it to be false. The runner, this context manager can also be used directly with the run function. So, you can use it in one single line. I mean, I split it in 2 lines because it is very long, but you can imagine this is all just one line, right? And you get this result object. Now, this result object is very interesting. It has some properties. It has a status, it has a return code, it has .run. .run is basically Metaflow's own run object, and through which you can access, the stored data inside of flow and stuff like this, and properties such as .finished and stuff. And then at any moment of time, if you want a snapshot of, let's say, the standard output or the standard error, you can just print result.stdout or stderror. In this case, this is a synchronous version of the API, which means that we will wait for the whole flow to finish. And since we will wait for the whole flow to finish, the result.stdout is nothing but the whole stdout itself. It's not the middle part of it, right? It's not a part of it. So let me just run Python runner demo to showcase how it looks. So I get the status as successful. I got my return code as 0. My run object is basically hello flow and / some run ID. And the snapshot of stdout is this. Now, this was very fast because this flow has literally nothing doing. So yeah, it ran in a couple of seconds. So that is how the API is supposed to look like. Now, of course, if you don't want to do things in a single line, you can remove this .run aspect of it. So let me comment out this one and let me go to the other snippet. So basically what you can do is you can just instantiate a runner and inside that call runner.run, right? So, what I'm trying to say here is you could either do .run directly or you could do it, separately as here. Then, it's just the same snippet. So yeah, wouldn't matter, the same output, the same result, everything is the same, right? So this is an example of a simple flow running the asynchronous API with the context manager and multi-line. This was a single line. So now you can also use this API without the context manager, of course. So you can declare the runner object for you, and then again do the same things that you were doing earlier. The only gotcha is you need to do runner.cleanup. Why? Because we create some temporary files, and otherwise they will be left hanging in your system. So it is just a way to clean them up, delete them, so to speak. So yeah, if you do this, you get the same output again. So I just showed you 3 different ways of doing the exact same thing. One using .run directly with the context manager, one with the context manager but .run in another line, and then without using context manager at all. Now, where it gets interesting is, right? Where it gets interesting is that if you remember the command line, how Metaflow is used in command line, you basically have Python flowname.py, and we can do minus minus help here, right? So that will show me some parameters, right? So metadata is a parameter, quiet is a parameter, environment, data store, etc. Now, all these parameters you can pass, and you can pass them, basically you can pass them at this level. So at the runner level, when you're declaring your runner object, all these different parameters you can pass here, right? So the flow level parameters. And if you were to do Python flow name run minus minus help, then this has its own set of parameters such as max workers, max num splits, and so on, right? And those parameters you can pass to the run function. So these are the top level. While declaring the runner and while actually doing the run, you can pass these parameters here, right? So once again, to revise, there are runner level arguments that correspond to Python flow name py minus minus help. Examples are quiet, metadata, environment, data store, etc. And these you can pass here while declaring the runner object. And while doing the dot run, you have some run level parameters such as max workers, max splits, whatever, and you can pass them here, right? So we can try, oh, sorry, we can try running this, of course. And yeah, it ran, and it ran very fast, right? Now, the great thing about this API, right? It has sanity checks. Now, what I mean by that? So first of all, if you remember the flow level parameters using minus minus help at the flow file, you get pylint, right? Now, pylint is a Boolean type. Imagine me passing 3, uh, right, to pylint. So type is Boolean, and I'm passing an integer instead. So if you try to run this, you will of course get an error. So invalid type for pylint. We are expecting an optional bool, and the default is true. So that is good. And so that there's type checking on the fly, number one. Number second is that, let's say I am, passing a parameter which is not supported by Metaflow. For example, I'm passing here Mathur equals school, right? So here also we have, type checking on the fly, and basically checking for valid arguments. And if I run this now, I will get unknown argument Mathur, and possible arguments are tags, max workers, and max sum splits, and so on. So you have, so you cannot pass unknown arguments, and you cannot pass wrong types, basically. And now once I have corrected these two mistakes, then of course I can run this demo again. And yeah, it will just finish in a second because it is that quick. Because the flow really is nothing, right? Now, what I can do further is let's consider another flow now. So this was a hello flow. Now we've graduated a bit. So let's come to another flow. The only difference this other flow has is I'm storing cell.x equals 3 here, right? That's literally it. So I'm storing data inside it. Now, what I can do is, of course, I can pass my runner level arguments, which I discussed, and the run level arguments here. Now, Metaflow has this something known as the run object, and result.run gives you the Metaflow's run object, and you can query what data was stored inside your flow using dot data and the variable that you stored it with. So dot x, right? So if you run this now, you would get x is 3, and that is correct because we stored x as 3 here, right? So you can imagine, storing your accuracy if you're training a machine learning model and accessing it later and using it to compare in your CI/CD if your training was correct or not and stuff like this.
You can even
Now,
imagine something like, you see the return value of X, and then if X is greater than 5, then execute whatever flow A. If X is less than 5, then execute flow B. So you kind of sort of construct a sequence of flows based on these values accordingly, right?
yeah. So we have discussed how to access data stored within the run object. You have discussed that arguments are sanity checks, the type checking on the fly, and you cannot supply unknown or whatever, any random parameters as well. Now let's come to another example of a flow. And this contains a parameter, a user-defined parameter called alpha, right? And this alpha is how much seconds should I sleep, right? So it is required, and the default value is 1. So in the flow, I'm just, printing, let me sleep for alpha seconds, and I'm waiting for that time. And then my flow proceeds to the end, right? Now, the good thing about this runner API is it dynamically injects all user level parameters also. So what it means here is that whenever the command line version, you would supply minus minus alpha, right? When you would do run. But here you would supply it here uh, because it is a run level argument after all, right? Now you can notice that I'm missing an alpha here, right? And I can only supply it as an integer because the required was true, and yeah, the default is one and the inferred type is integer. So when I try to run this, of course, I get missing argument alpha is required. So the beauty about this API is that the type checking and the validation of missing arguments and um, unknown arguments that you supply, it also works for user supplied parameters. So they are injected at the correct place. And this would also work for, let's say, trigger commands of Argo workflows or SEP functions and so forth, right? So they are injected at the correct place. Now, let me supply alpha, of course, because it is asking us to. So let me supply it as a string, and that would be my name. And of course, it should result in an error again because it is expected to be an integer. And of course, we get invalid type, expected integer, default is 1. So let me sleep for 5 seconds now. So this flow should take 5 seconds to complete. And if I run this, it is waiting for 5 seconds. And yeah, it took 6 seconds because 1 second for the startup time, setup time, right? Now, all these were, of course, you're running flows locally. We can also, I mean, if you have, your Metaflow set up correctly, then of course you can ship to Kubernetes and other remote execution environments. And if you remember, the way we did it was, Python and your flow name and your minus minus with Kubernetes and so forth, right? So with is a reserved keyword in Python. So instead of with, we have something known as deco specs here. And since the run command comes after, oh, sorry. So since the run command comes after, the with argument in the command line, so that's why this with is nothing but a flow level argument. So that's why it comes here in the runner, uh, runner arguments and not really the run arguments, right? Now, of course, this assumes if you want to ship to Kubernetes that your Metaflow should be, set up correctly and stuff. So I have another terminal where I do have the Kubernetes set up. So let me try to run it there. I think it might ask me for my authentication and stuff. So yeah, just let me quickly. Yeah, it did, right? Yeah, let me just put my code. 1 second. And let me cancel this because, of course, the code wasn't there. So there were auth issues. Okay. Now, since the code is there, let me just run. Now, this will actually run on Kubernetes for you because we are supplying DecoSpecs, Kubernetes, and retry. So every step will be, decorated with the Kubernetes decorator. And alpha is 10, so it should sleep for 10 seconds. But since it is on Kubernetes, so it might take a bit longer to set up the pods and stuff. But the flow itself should take 10 seconds, right?
And here, if you set the show output equal, actually your show output is true. Should it show the pod name and the logs from the pod? Oh,
It
here
will.
it is. Yeah. Oh, okay.
It will show whatever you get in std out normally.
Yeah.
And
Yeah, there it is. Nice.
yeah, so pod is running, container is running, and so on. So I guess we can wait, or we can also skip ahead. Or maybe let's just wait. It's not long anyway.
Mhm.
Yeah, so now it is actually skipping for 10 seconds, I guess, because that was the first task. Now it's at the middle task.
So this runner API code itself is running on this workstation that you are on, right? Like on this
Yeah, it's
machine
my
that you
local,
are
it's my
current.
local machine. It's my local
Yeah,
machine.
local machine. And from there, it is essentially running what otherwise user would have run, like Python floor pyrun with
Yes.
Kubernetes run. It
Yes.
is doing that, but also passing in all the arguments and kind of sort of whatever, streaming in the result, the standard output, and showing it here and so on. Right.
Yeah. So this is something. So we saw it worked. Now let's come to another flow, another example of a flow. Now this is a flow that can fail non-deterministically. So I have a, I'm tossing a coin basically, and with 50% probability, I'm trying to convert a string to an integer, and with 50% probability, I'm doing the correct thing. So obviously, I can fail half the time, I can, succeed half the time. So this particular step, the mid step, can actually fail randomly for me. Yes. Uh, so what I can do is, so this runner API also, has resume, right? So uh, basically I have my runner thing again, then I have my number of attempts is 1, then result is run.run. Now, tcall that result had, a lot of properties, which I showcased in the first example. If the result is actually failed, let me try again, let me increment my number of attempts, and then do runner.resume. Now, this resume is, of course, if you've used resume functionality of Metaflow, you know that it resumes from the failed step. So you don't really execute from the start. So if I run this, the attempts would be much faster than you know, the whole flow, because it's just resuming from failure, right? Oh, sorry. I'm actually running on a context which is, which is configured for remote execution, and that's why it was taking time. So let me switch back to my normal terminal instead, right? Yeah. So yeah, this finished much faster because that one was for cloud, right? So it was, yeah, it took only one attempt, but let me just run it once more and see that, it's actually non-deterministic. Yeah. So 5 attempts. So on an average, if you run this 1,000 times with the probability of, yeah, you'll get your number of attempts to be half because it's probability of 50%. Yeah. So we have run, we have resume. Now, all these examples that I showed you, they were basically synchronous API of the runner. We do have a very cool asynchronous API as well. And I'm going to show that as well here. So of course, with everything asynchronous, I'm wrapping it inside an asynchronous function because Python doesn't support top level awaits by default. But here, what you can do is it is an example of a single line again. So I have the runner here, and I'm also calling async run, right? And everything is one line. I mean, it is longer. That's why I split it up for readability, but everything is just within one line, right? And of course, it has these properties again and again. But what you will notice here is that in the previous examples, if my alpha was 5 seconds, I was getting these results after 5 seconds. Yes, because it was actually waiting for the flow to complete. Here, I'll show you that I'm waiting for 20 seconds, but I'll get these results instantaneously because it is an asynchronous API. And what it means is that you can, play around with this result object. And as I said, the std out is a current snapshot of std out at that moment in time. And since the flow hasn't finished yet, because 20 seconds wouldn't have passed, so the snapshot would be kind of, not full in some sense. So if I run this, yeah, so you get status as running. Your return code is none because it is not completed yet. The run object is this. The std out snapshot is this at that moment in time, and the process ID was 8004. And I can actually, go in psaux grep Metaflow, and I can see the process ID was 8004, as you can see. So it's still executing in the background here. Yes, because it is an asynchronous API, right?
And if I do want to wait for, I mean, let's say I want to continuously read the standard output, like,
Yeah,
is
yeah.
there a way
I'm
I could
coming.
write a,
I'm
oh,
coming
sorry,
to
sorry, go ahead. Sorry, go
streaming.
ahead.
Now, of course, I can wait for, the flow to complete. And the way to do it is using this await result dot wait. That's it. And the cool thing about this, the result dot wait, is that it returns itself. So what I mean by that is you can do result equals to await of result dot wait because it returns itself. So then you can access other properties again and again, but let's just wait for it, right? So I'm waiting for 5 seconds here. And I mean, here you are converting your asynchronous version back to synchronous version. So you might as well use the synchronous version, which I showed before. Yeah, and it took 6 seconds, as you can see here, right? Now this wait function that I showed you, right? It has some cool things. So I can wait, but I can also supply a timeout. So I want my flow to be completed within, let's say, 7 seconds. Now, of course, here it would fail because I'm passing alpha as 20 and I'll wait for 20 seconds, but I'm passing a timeout of 7 seconds, which is lower. So let's see what happens in this case. So yeah, so we had a timeout which was incurred after 7 seconds, and the underlying Metaflow flow was killed, right? And it was supposed to run for 20, but it killed itself after 7 because of the timeout, right? If you don't supply anything, it of course waits till the end, which I already showed. Now this wait function can also take in a parameter known as stream, and you can actually stream logs. If I pass std out here, we'll be streaming standard out. If I pass std error here, we'll be streaming std error. So yeah, so I'm waiting. So this is live streaming from the asynchronous run, right? And yeah, we've already waited for 5 seconds and we are kind of done, right? Now, of course, you can use both stream and timeout parameters. So stream std out and timeout 7, right? That will mean you are also streaming while also timing out at 7 seconds. And of course, it will fail after 7 seconds. Yep. Cool. So now we can have more control over log streaming. So let me uncomment this complicated example that I have here. So what happens is that, I mean, this statement is similar, say before. Let's say I have an interesting position, a variable called interesting position, and that is 0 for now. We also have a function known as streamlog, and result.streamlog, you can pass it, uh, the stream, the std out or std error or whatever, and then you can, loop on it basically. So you can loop on it line by line, right? So you're looping on it and it returns two things, so position and line. And position is calculated after the line has been read, right? So I read a line, I print it, and if I find alpha is substring in that line, then I record that interesting position and I break out of this loop, right? Now I ended streaming basically at this interesting position, and I can also resume streaming from a particular position. So the stream logs thing actually takes a position argument as well, and I am resuming from there, and then I'll print lines only from that particular position and not from the beginning, right? So I can read logs halfway as well. And then by here, what would happen is that what would have happened is that, the process would have ended by now. And since it would have ended, and if I try to stream again from scratch, this will be instantaneous because it has already ended. I am just reading the log file, right? So let me showcase that as well. So basically, we'll have three outputs, three chunks of standard out outputs. So here is the partial one, the beginning. I ended streaming at 232 and I'm resuming it from 232. But since I'm waiting for 20 seconds to get over because it is part of the flow, that's why you don't see anything here yet, right? Yeah. And then once you resume streaming, you get the logs after that position. And then once you're done, you basically stream again from scratch, but this was printed instantaneously. And you can verify that because the total time of execution is still 21 seconds because my flow ran for 20 seconds, right? So let me comment this out as well. So this offers you a more fine-grained control, so to speak, over your log streaming, where you can iteratively, search for substrings in your logs and so forth. Let's do something even more cooler. So here I have a function called emit logs. It is basically a wrapper over, result.streamlog. It just loops over it. And whatever I can supply a function, let's say a custom logger. In this case, it is a print function. But imagine you are shipping logs to, let's say another service or a SaaS tool that you use or whatever, right? And you can use that particular logger here. So it is basically iterating over the stream log and using custom logger over that. Now I create my runner object with the particular flow, right? And I have two results here, result A and result B. I run basically two invocations of that flow, but with different parameters, one with alpha is 20 and one with alpha is 30. And then I create two tasks, and two tasks are nothing but invocations of emit logs. I pass the result object, I pass which stream I want, and in my custom logger, I modify my print function to have these prefixes, stream A and stream B, right? And then I'll wait for both of them to happen in parallel and together, right? So if I run this, so you see stream A logs and stream B logs. So task is starting for both of them, right? And then alpha is 20 for one, alpha is 30 for another. Yeah, so you can do cool things like this with the asynchronous version. And of course, since they both run in parallel, so the total time of execution will still be 30 seconds because the 20-second one is subsumed under that running time because both are happening in parallel, right? Yeah, so 32 seconds, as we can see, the execution time and both logs appear here and that too in parallel, right? Then, of course, I can launch many parallel runs, right? So I have my runner here. I create an array of runs that I'm launching, each waiting for a different amount of time period. And as and when I get the result, I'll just be collecting them and showcasing that, hey, this run completed, that run completed, and so on. So I'm launching 5 runs here. One sleeps for 5 seconds, the other for 10, and so on. And as you can see, all 5 are running, then one is completed, then 4 are running, then another will be completed, and eventually all will be completed. So this asynchronous API gives you, ability to stream logs, capture the standard output at a particular snapshot, and so on. Now, for the last part of the demo after this, I'm going to show you how to, run this inside notebooks. So I'm switching here to my notebook. So for notebook as well, the thing is, we have a different runner for notebooks because we don't have a file. So it's, you basically import NBRunner, and it's of course built on top of the runner. And imagine your flow, being written in this cell only. So the thing about, there is a small gotcha with NBRunner. It needs to be initialized in the same cell in which you have your flow. So basically, since your flow is present here in this particular cell, so it has to be initialized here. So this is one small gotcha. And of course, then it mimics the runner because you can set your, the flow level arguments here. And when you access the .run function of it, then you have your run level arguments here. So it will come with all the sweet type checking and validation of arguments and stuff, right? But yeah, you need to basically have it in the same cell, the instantiation of it. So it needs to be self-contained in that sense. So once, of course, you import it, and this is also non-deterministic. It fails with an 80% probability. So yeah, we are just trying. We'll just wait for it to, run. It's basically the same. I can actually just stop it to save time. But it's basically the same, exactly the same usage, right? So runner.run, num tries one. When it is not successful, try again, runner.resume. Yeah, I stopped it. Yeah, so we can ignore that. And of course, you can print the std out, std error, status, run.finish, where the log files are, the return code, and so on. So this is your NBRunner, the synchronous version of it. And since I showed you the asynchronous API as well, we have the NBRunner asynchronous run, right? So when you have asynchronous run, you get the result immediately, and you can do result.status, which is running, of course. And I showed you the wait API. So you're waiting for the log streaming, the streaming of standard output. And then since it failed because it was failing with non-deterministic probability, 80% probability. And of course, if you print status, it has failed. And just like we had an asynchronous run, we also have an asynchronous resume. So it is very similar. It's just the same thing essentially, right? So runner.async resume, and yeah, if you do the status, you have it running again. And if you stream it out, and this time we got lucky because it actually passed. And here you have result.status, which is successful. So these are two examples of using NBRunner with the synchronous run, synchronous resume, and the asynchronous run and asynchronous resume with log streaming and all these things. I have one last example which makes things even simpler. If you don't want to bother with all this, just use NBRun. NBRun is a very short gotcha for, hey, I just want to run this, give me the output. That's it. Nothing more to do. And yeah, it will give you the output. And similarly, you have NB resume. So if you don't want to get into the best practices of using it, you just want a quick way of doing this, just use NB run and NB resume. So yeah, this is just for making life more simpler. But otherwise, if you want the full feature set, you should actually use async run, run, and so on. So yeah, this wraps up the demonstration of the Runner API. And to go very quickly into some lower level details, it's a 3-layered architecture. We have a lower level API, we have a sub-process manager, and this higher level API is built on top of it. And the lower level API is where the magic happens of type checking and validation of arguments and so on, right? So that is something. And it's a bit of reverse engineering because this is basically, if you execute Python flowname.py, then you have some arguments at this level, and you have command groups run. You have command groups of Kubernetes, and Kubernetes has its own command step. So C denotes a terminal command here. G denotes a group, right? And Argo workflows is also a group, and then it has several commands as create and trigger, right? And at every level, you have these arguments or parameters. So we basically, it is a tree data structure. We basically reverse engineer and parse this tree structure at runtime to construct the lower level API. And as you can see, the user defined parameters were alpha, right? So alpha in my file, for example, they are injected here dynamically for the run command and wherever it makes sense. So it also makes sense in trigger. So that's why they are injected here as well. So yeah, that is some interesting reverse engineering aspects of it, right? Yes. And of course, if you want more information, then we have a documentation present here, which we can send on Slack. And we recently also had a blog post about it. For upcoming, there might be some bugs, but happy to have feedback and fix them. And basically, we also have, just to give a teaser, we also have upcoming runners, or let's say deployers, for Argo workflows and step functions, which will have programmatic APIs of doing those two as well. So yeah, hope that's all.